Hello, and welcome to the world's best iOS development course. My name is Angela, and I've been working as an iOS developer for over 7 years. As a part of my job, I work as the iOS lead at the App Brewery. I also teach on our in-person programming bootcamp. And today, I will be your instructor on your development journey. As a student on this course, you're going to get access to over 55 hours of HD video content, which contains step-by-step instructions to teach you how to build over 25 fully fledged iOS apps. So if you're somebody who wants to get a job as an iOS developer, then this is perfect for building up your portfolio to show off at your next interview. On the other hand, if you're somebody who wants to build your own apps for your app business, then in addition to all of the programming lessons, I've also included full modules on app design and app marketing, so that by the end of the course, you'll know how to build, design, and publish your app onto the App Store. Now, this course assumes absolutely no programming experience. So if you're a complete beginner, then I will be there for you every step of the way as I take you through fundamental programming concepts all the way through to intermediate and more advanced programming techniques. Now, if you're an experienced developer, on the other hand, there's plenty of advanced Swift programming concepts as well as design patterns to sink your teeth into. At the App Brewery, we have over 250,000 students worldwide, so that means you're never going to be alone in your learning journey. You're going to get access to our private student community where you'll be able to ask questions, get advice, find co-founders, and work through the course together. Now, as if all of that wasn't enough, you're also going to get to download my 12 Rules to Learn to Code ebook, and you're going to get access to a design package that'll help you when you start building your own apps. With over 39,000 5-star ratings and reviews, my iOS courses are the highest rated in Udemy history, and this iOS course is going to be even better. At 55 plus hours, this is my longest course yet, and it includes some of the latest and greatest technologies that Apple has released, including a comprehensive module dedicated to SwiftUI. We'll learn all of the ins and outs of this new technology and use it to build fully fledged, complete apps like this Hacker News app. You're also going to learn about ARKit and CoreML, which you'll use to build this Pokemon Go style app and this magic newspaper app, just like the ones you see in Harry Potter. As a student on this course, you're going to be saving yourself a lot of time because all of the lessons in the course have been completely updated for the latest versions of iOS, Swift, and Xcode. You're also going to be saving yourself a lot of money. This course has exactly the same curriculum as our in-person programming bootcamp. So instead of spending thousands of dollars and taking time off work, you get access to the same curriculum that has taken years to develop to ensure that you don't just know what you're doing, but also why you're writing the code and what it does. Now, don't just take my word for it. Check out what some of my past students had to say about the course. So what are you still waiting for? Find out why over 39,000 students have rated this course 5 stars and see what they've been able to build. I look forward to having you on the course. Hey guys, welcome to yet another Swift deep dive. And in this deep dive, we're going to talk about structures. Now, structures helps us create custom data types. So whereas previously we saw that there were loads of basic data types that comes pre-built along with Swift, for example, strings, ints, floats, doubles, booleans, arrays, and dictionaries, you name it. There's a whole lot of different pre-built data types. But what if we needed our own data type, something that groups together related properties and behaviors? For example, our quiz questions. Currently, we have a 2D array, which basically forces these two pieces of data, the answer and the question, to be associated with each other. But actually, these are two properties of a question, right? The text of the actual question as well as the correct answer of a question. Those should really somehow be interlinked together. And in order to do that, we could use a structure. So we create a structure by using the struct keyword, and then we give it a name. Now, notice how the names of structs are a little bit different compared to methods or properties. When you're creating a struct, the name that you give it has to be capitalized even at the beginning. So that way you can tell that it's actually a data type. Similar to how our string, int, or float data types all start with a capital letter. Let's go ahead and create our own structure in Playgrounds. So let's say that I was to create the structure of a town. Well, I would start by writing the struct keyword, and then I would give my structure a name. So let's just call it town. And then I'm going to open a set of curly braces inside of which I can define the properties of my town. So what are the kind of properties that a town might have? Well, it might have a name, right? So let's create a constant using the let keyword and give this constant a name of name. So the name of the town. And then I'm going to give it a value. So let's call it Angela Land. Now let's think, what are some other properties that a town might have? Well, it probably has some citizens, right? But in this case, I'm going to create a variable. And the variable is going to be called citizens, and it's going to be equal to an array. So these are all the people that live in Angela Land, and it will be myself and let's say Jack Bauer, my ultimate hero. And so now that we've got the citizens who live in the town, the name of the town, the last property I'll add are the resources in this town. So let's say that we had some grain, maybe 100 bags of grain, some ore. I think I've been playing a little bit too much of Settlers of Catan recently. This is all I can think about. Let's say we had 42 blocks of ore. I'm not sure what's the unit of count of ore. And then let's say we had some wool. Notice how here I'm creating a dictionary. So it's a variable called resources, which is a collection of dictionary items. So we've got our key and our value. So 100 bags of grain, 42 bags of ore, 75 bags of wool. And these three properties are now all packaged together into my town structure. Now that we've created our struct, it's time to actually initialize it. By initializing, I mean creating an actual object that we can use. So to create an actual town from our town structure, all that we would need to do is create a new var, and this var will be called my town. Now, this my town is going to be the actual town created from this structure. And to express that in code, we would write var my town equals town and then a set of parentheses. So now what I've done is I've created a new copy of this town structure, and it's held within the variable of my town. So that means I can actually use this object my town, and I could access the properties of my town. For example, I could print my town, and to access the properties, I would use the dot notation. So as soon as I write dot, you can see all the things I can tap into. And let's say that I wanted to print who are the people who live in my town. I'm going to print my town.citizens. And currently it's just me and Jack Bauer. Now I can tap into some of the other properties as well. So for example, if I wanted to use my string interpolation to get hold of my town.name, so the name property of my town, and then let's say my town has, let's do like a little report, shall we? How many bags of grain have I got? So then it would be my town.resources, and then we would use the square brackets to access the grain key. And then we could say, well, it has this many bags of grain. So now if I run my code, you can see that these are the citizens and Angela Land has 100 bags of grain. That's a pretty good town, if I might say so myself. Now with the object that we've created, my town, we don't have to limit ourselves to just retrieving data or retrieving the values of properties of this object, but we can also add and modify it. So for example, if let's say that my town has a new citizen, let's say that Keanu Reeves decided to move into this wonderful town, well then I might say my town.citizens, so it access the citizen property of my town. Well then I can append, so add something to my citizens array. And the name that I'm going to append is of course our new neighbor, Keanu Reeves. So there's 3 of us now in our town. And I can print, for example, my town.citizens.count. And when I do that, you can see that after I've added Keanu Reeves to the citizens of my town, we now have 3 people living there. Whereas previously, when I printed my town.citizens, we only had 2 people. Now, so far, the structure of our town only defines the properties of a town. So towns should have names, towns should have citizens, and they should have resources. But we can also define a behavior of our structure. So we can make towns be able to do things like build barricades and, get everybody inside, and we sort of eat all our 100 bags of grain. And to do that, we would simply just create a function within our structure. So let's say we created a function called fortify. And now, inside this fortify function, we could simply just, for ease of use, we'll just print defenses increased. So now our town structure has properties and it has something that it can do. Now, when we have a function that's associated with a structure, well then the name for it is actually called a method. So if you hear the words functions or methods when people refer to it on Stack Overflow or online, just know that they're both referring to this same thing, the thing that we create with a func keyword, and it defines some behavior inside the curly braces. But if this behavior was defined inside the curly braces of a structure or a class, then we would call it a method. But if it was sort of standalone, free floating around somewhere, well then we would call it a function. At the end of the day, it's just defining behavior, something that it can do. But now I can trigger this method or this functionality that my town has by writing my town, so this is the actual object that can do things and has properties, dot, and I'm going to make it do something. Now notice here that this M stands for method, and if I hit enter, then my town is going to fortify itself when I run that line of code. And we can see that my town has its defenses increased, so it's able to perform an action or a behavior. When we create a struct in our code, we're essentially creating a blueprint for an eventual object that will get created from our blueprint. And in this blueprint, we get to plan ahead for how this eventual object will be. For example, we create variables, and when our variables live inside a struct, that variable is associated with our struct, and it's known as a property of that struct. Similarly, we've created functions inside our structs, and when functions are created inside a struct, they're known as a method. So you can consider these properties as a way of defining what this eventual object created from the struct will be like. So its attributes or its properties. And the methods can be thought of as what the object can do. So in the context of an actual car object that gets created from a car struct or car blueprint, well, those properties might be things like the color of the car or the number of seats it has,
or the number of doors it has, or whether if it's a hatchback or a sedan, something that describes what this eventual object is going to be like. And the methods for the car, well, those are things that the car object can do. So things like drive or brake or switch on the indicator lights. And it's through describing these properties and methods of the objects that will get created when our app is running. So these objects are invisible. We can't see them, we can't touch them, but we can plan for how they will behave and how they will look by creating these properties and methods. So when we were defining our town struct, we were writing the blueprint for the eventual object that will get created. And we can take our blueprint and initialize it, which turns it into the actual object, in this case, maybe an actual car. But what do I mean by that? What does initializing mean? And what does the code actually look like? Just like we would create a function, we create our initializer in a pretty similar way. We have our parentheses for the inputs that gets passed over. We have our curly braces for the implementation or the code for how to initialize our structure. So how does the initializer get used? Well, the initializer gets triggered when we create our object from our blueprint. But why do we have initializers in the first place? What's the purpose of the initializer? Well, suppose you want to create the next Civilization or Settlers of Catan video game. Well, in that case, you're going to need more than one town, right? Well, in addition to Angela Land, you'll need Athens, Beijing, and New Delhi, and many, many more. But all of these places are different. They have a different name, different citizens, and different resources. Wouldn't it be nice if we could use our struct to act as a blueprint for all of these towns, but still be able to customize each town? Well, that's where the initializer comes in. Let's head back into Playgrounds to see this in action. Let's delete everything we have here currently and just be left with our structure. Now I'm also going to delete the values of these properties to keep my town very generic. So the name is going to be a string data type. The citizens are going to be an array of strings, and the resources are going to be a dictionary made up of strings for keys and integers for values. So now my town structure has blank properties for each of these attributes, and I can now define a custom property every time I create a new town. But before we do that, we need to create the initializer. So I'm just going to write init, and when my Swift code snippet symbol comes up, I'm just going to hit enter. And inside the placeholder, which says parameters, I'm going to add some input parameters. So when I initialize a new town from my town structure, I'll be able to use these inputs to fill in my properties. The first one is going to be town name, which is going to be of type string. Next, it's going to be the people of the town, which are going to be an array of strings. And finally, I've got the stats for my town, which is going to be a dictionary comprised of string keys and integer values. So that's all three inputs that I need for my initializer. And inside the initializer, what I'm going to do is I'm going to set my town's name property to equal whatever got passed in as the town name. And then I'm going to set my citizens property to equal whatever got passed in as the people of the town. And finally, my resources property is going to be populated with the stats that have been inputted for this town. So now if we're creating our town with an initializer, the way that we would do that is let's create a variable called, I don't know, another town. And let's set it to equal a town created with our town blueprint. And then once we open a set of parentheses, you can see all of those input parameters show up: town name, people, and stats. So if we hit enter, we can use these placeholders, and you can hit tab to go between them. And we need to provide some values in each of these positions. And we can also see what type of data we need to provide. So the first one for the town name has to be a string. So let's call this nameless island. And the people who live in this nameless island will just be one guy, and it's going to be Tom Hanks. And for the stats of this town that I'm creating, it's just going to have a whole lot of coconuts. And let's say it's got 100 coconuts on this nameless island. So now that I've created another town, I can do exactly as what I've done before. I can tap into my object, the another town. So remember, the object is the thing that's actually created from the blueprint. And I can, of course, print the properties, say the citizens or the name. I can call or trigger the methods or the behaviors that the town can do, namely fortify itself. But I can also, of course, tap into, let's say, our citizens. And then, just as we did before, we can append a new element, which happens in this case to be a beach ball who's going to join the citizens of Nameless Island. And he's going to be called Wilson. So now we have another town, which is an object created from the town blueprint with all of these properties that we've specified when we created the town using the blueprint. And we're able to use this object just as we did before to tap into its properties or to manipulate or change some of those properties. And we can, again, if we wanted to, now print our another town, so our object's property. Let's print and see who lives in this town. So this time it prints there's Tom Hanks and there's Wilson on Nameless Island. Now notice how I'm twisting these names so that they don't overlap with the names I've got as the properties of my town. Because in reality, it would be much easier for me to just name this name this citizens, and name this resources. But now, when I initialize it, I have to set the name equal to name and the citizens equal to the citizens and the resources equal to the resources. Now, it kind of makes sense if you really think about it. So I'm saying that the name property of my town structure should be set to equal the name that got passed in as the input parameter. But this code is very confusing because this name matches exactly this name. Now, what else can I do? Well, I can make it really explicit which one I'm talking about, whether if it's the property or whether if it's the input here, by simply adding the word self in front. Now, you might have already come across this keyword self, and we haven't really gotten around to explaining it, and this is the perfect time to really explain it, because the self keyword refers to the eventual object that will be created from this structure blueprint. Whereas right now we're saying self.name referring to the property name of our structure town. Well, eventually when we try to initialize our town, that self is going to refer to the object that's initialized. So for example, the another town. By adding that self keyword in front of all of these properties, I can now easily differentiate them by saying, well, self.name, of course, refers to my town's name property. Self.citizens, of course, refers to my town's citizens. And you can view this self keyword as referring to the structure. Now that I've changed the parameter names of my initializer for my town structure, well, I also have to change them here, right? So this is what this error is about. It says that the labels should be the name, citizen, resources, but instead we have town name, people, and stats. So we can go ahead and click fix for it to change it for us to the ones that we specified in the initializer, and all the errors go away. But from now on, also, when we create, say, let's create a ghost town from our town blueprint, and when I hit enter, you'll see that these are now the parameter names I have to provide. let's create our ghost town, which is going to be called Ghosty Muck Ghost Face. And the citizens are none. There's nobody living here because it's a ghost town. And the resources are, it's just got like a lot of tumbleweed of 1. It's just tumbling around in our ghost town. So notice how right now I've got one object created from my town blueprint, which is called another town. And in there, we've got Tom Hanks with a bunch of coconuts. And we've got another town called Ghost Town, which again, we've created from exactly the same blueprint. But this town's completely different. It's got a different name, it's got no citizens, and it's got just a single tumbleweed. Tumbleweed. So now when we tap into our objects, let's say that in another town, we've got a new citizen who's moved in. So we'll append Wilson to that town. Whereas in the ghost town, well, nothing really happens, but let's say that we just decided to fortify the town. Notice how here I'm tapping into different objects that have essentially been created from the same blueprint. And when I hold down Option click on each of these objects, you can see that they both have the same data type. They're both created from the town structure. But they are really different from each other. They have different names, different citizens, different resources, and I can specify which one I want to manipulate, which one I want to change, whose properties I want to tap into. And now we've got essentially a whole bunch of things that we can play with by using this blueprint as a starting point. So now that you've learned all about structures, it's time to test your knowledge in the structures assignment. So head over there before you continue in the project. And once you're back, I'll see you on the next lesson. Now, in the last lesson, we got an overview of how apps work on the phone. So in this lesson, I want to take you one step further and look at how apps are made from beginning to end. Now, one of my favorite shows of all time that you get on Discovery is a show called How It's Made. And it basically takes you into the factory and shows you how a bunch of random things get built on the factory floor. Things such as street bicycles, or floors, or drum crushers, or skateboard wheels. And I just find it so fascinating seeing how all of these everyday objects gets made and built. So if you're curious, have a look at some of the episodes, and there's some real gems in there, like how rubber gloves are made. And it shows you every step of the factory process, from dipping it in latex to drying it and rolling it. And I don't know why, but I find it so interesting, the process that's involved in creating all of these everyday objects. So that's what I want to do here. I want to do a special episode inspired by the show on how it's made, the app episode. So the app industry is absolutely massive. Last year, Apple reported it paid app developers $26.5 billion US, and that number grew by 30% year on year. So it's a massive industry, and it keeps on getting bigger. Now, of course, some of that money goes to big companies such as Clash of Clans or Clash Royale or some other form of clashing. But there are also a lot of stories of independent one-man developers who have made it big on the App Store. And one of the best examples is the 7-minute workout app. Now, in the course resource list, I linked to the article that's written by the maker of the 7-minute workout app, a guy called Stuart Hall. And by himself, he built an app that got 2.3 million downloads without spending a cent on marketing, which generated him over $70,000 US in profits, and was acquired and sold to a company just after 18 months. It's a really fascinating read, but he goes through the entire process of how he built this app from idea to app store, all by himself with no budget. Just the skills and know-how of how to build an app and the grit and perseverance of an entrepreneur. So I know that you're taking this course for various reasons. Some people want to get a job as a developer. Others just want to gain a new skill and make apps for fun. and other people want to build a business based on an app. But before we get started and really dig into learning and building our apps, I think it's really important to first have an overview of the entire process from beginning to end of how an app is built. So step 0, before you do anything else, is why. Ask yourself, why do I need an app? And in many cases, you actually don't. If you just want to build an app that simply displays data or information, say the opening hours of your shop or the services that your business offers, then you don't actually need an app. You can simply build a website that looks good on mobile, and that will take far less time to build, and it's much easier to do. But however, if you need to tap into the sensors of the phone, or if you want to be able to push notifications to the user, then you probably do need an app. But just make sure that you're on the right path before you even begin. Now, once you're sure that you want to build an app, then the next step is the idea stage. Not just coming up with an idea, which is the easy part, but validating whether if the idea is actually a good one. So let's say that I'm bored of swiping on Tinder for my next match, and instead I want to find my perfect match in the form of a Sunday roast. So what if I have an idea for an app that's called Tender, and it's going to match me with the dish that I fancy the most right now. And it could be a delivery app such as Uber Eats or Deliveroo, where I get that meal made and sent to me, or it could be just a recipe app where I try to find the thing I want to make today. So here's an app idea, but how do I know if it's actually a good one? Well, that's when you would need to validate the idea. Talk to lots of people and get a diverse range of opinions. Make a minimum viable product that doesn't require any technology at all to test and see if people are actually interested. Or put up a landing page describing your idea and promote it on social media and see if people actually want it. And essentially what you're trying to establish is, once this app gets made, will people actually want to download it and use it? Now, once you figure that out, then you're ready to move on to step 2, which is designing the app. And in this App Development Bootcamp course that you're enrolled on, I've included full modules on app design. So you'll learn how to build wireframes, how to build prototypes for your app, and learn how to use all the tools and the design principles to make not just a functional app, but a beautiful app that people will love. And then you can move on to step 3, which is the actual development, the programming of the app. And that is going to take up most of our time in this bootcamp. We're going to be building over 25 apps. And through the process of building these apps, we're going to be learning all of the fundamentals of iOS development and the Swift programming language, so that you become a well-rounded developer and you'll be able to tackle new problems that you haven't seen before or build custom features once you've completed the course. So let's take our Tender app, and let's say we've written all the code for all the functionality of the app, and we've developed and built it. Then the next step is to test the app. And I'm going to tell you about automated as well as manual ways of testing your app so that it looks and works well on all devices, so that people all around the world, no matter which phone device they have, will be able to enjoy using your app, so that you can get those 5-star reviews that are crucial for your app to get more downloads. Now, step 5, we're ready to publish it onto the App Store. And I'll tell you all of the ways that you can get press for your app launch, and also what are the rules behind getting your app featured on the App Store. Now that you've made and published your app, the next step is to tell people about it. So in this bootcamp, there's a full course on app marketing as well, where I show you all of the ways that you can get your first customers, get your loyal fans, and start getting those downloads and making revenue off the App Store. Now, finally, step 7. As with all great things, you need continuous feedback and continuous improvement. So when your app is live on the App Store, you'll start getting reviews of people who want to request other features, or they have suggestions, and you can take some of those on board and update and refresh your app and continuously improve your user's experience. So that's a very quick and broad overview of how apps are made from beginning to end. Now, if you scroll to the very bottom of the curriculum, you'll find that I've included a full-length version of this lesson, and it's a talk that I give often at conferences, hackathons, and various events, and it goes into far more detail on every one of those steps that I've talked about in this lesson. So if you're interested getting more details on each of the steps and seeing each of the steps fleshed out, then head over there and take a look at that talk. And then once you're done, continue back where you left off in the curriculum track, and we're going to get started building our very first app. All right, so in this lecture, we're going to be covering some of the tools that you'll need in terms of software and hardware to start developing for iOS. First and foremost, you will need a Mac of some sort. Now, it doesn't have to be the latest or the greatest, but it just has to be able to run OS X. So it's now called Mac OS. And the reason why we need Mac OS is because we need to install a piece of software called Xcode that will allow us to develop our iOS app. So this means that iPads, even iPad Pros, are out of the question. But if you had a iMac, or if you have a MacBook, or even a Mac Mini, it will work just fine. So if you don't already have a Mac and you don't want to invest a lot in, a brand spanking new top of the range MacBook, then one of the cheapest ways is probably just going onto eBay and getting a secondhand Mac Mini for around $500, and it's a pretty great deal and it'll do just fine. But what do you do if you only have a PC? Well, the other option is that you can go for something called Mac in Cloud. So if you head over to macincloud.com, they have a service where essentially they offer you a Mac in the cloud. So you can be using your PC and you have a remote connection to a Mac that is just for you, and it's already got Xcode pre-downloaded, so you can just get up and go. Now, there's a lot of people who ask about Hackintosh, or how can you run a Mac, sort of dual boot a Mac on your PC without having to pay for a service like Mac in Cloud. Well, there's a number of ways that you can do this, but one of the major downsides is that Apple is very strict about controlling their software and the environment in which their software runs. So even if you're using Mac in Cloud, or even if you're using a Hackintosh solution, you won't be able to run your app on a physical iPhone device that you own. The only way that you can do that is by having an actual Mac. But you will be able to run it on a simulator inside Xcode. So this is a simulated version of an iPhone, and for all intents and purposes, it will work just as well. It's just, say, if you're really excited about having your app on your iPhone, then you really need to find a way of either borrowing somebody's Mac or getting one cheaply. The best resource, according to past students, is a website called Hackintosh.com. It talks in detail about how to run macOS on a PC. But I would still recommend try out some of the earlier solutions rather than going towards building a Hackintosh. It's just that we've had a lot of students on the in-person programming bootcamp who've tried to do this, and it's always given them a lot of headaches. So if you can really try and avoid this, this is almost the last-ditch solution. Now, the software that you'll be using is Xcode, and this is a piece of software that's written by Apple and allows you to write code, allows you to design your app, as well as run your app within the simulator that it comes with. And this is completely free, and in the next lecture, we'll be showing you how to download it and how to get it set up. But in order to be able to download the latest version of Xcode, which is Xcode 12, you're going to need to update your operating system to at least macOS Catalina 10.15. If you're already running macOS Big Sur, that's fine as well, of course, but note that macOS Catalina 10.15.4 is currently the minimum requirement to run Xcode 12. So if you find that you're unable to download it, it might be because you need to update your macOS operating system first. To check which version of macOS you're running is super simple. Simply just head to the left upper corner where you've got the Apple symbol, and then go to About This Mac, and you should be able to see the versioning right there. In order to update the latest version of macOS, all you have to do is head over to the Apple symbol again, go to System Preferences, and then go to Software Update. Here you should be able to see the update for macOS Catalina, and you can simply click through the wizard to update your macOS. Now, another thing to note when you're updating your macOS is to check the age of your laptop or your desktop, because there are certain hardware requirements in order for us to be able to install the latest version of macOS. So here I've included a list that Apple has given, so check your computer against this one to see if you meet the requirements. But if you do have any difficulties updating your macOS, then this might be one of the reasons. And if this happens to you, it might be that you have to go down the Mac in Cloud route, or you might just have to pick up a cheap version of a Mac Mini off eBay. But that's a tip that trips up some people when they're updating their OS. So when you're testing your app, you've got the choice of either testing it on a physical device if you own an iPhone or an iPad. So because the course is aimed at teaching you how to make apps for iPhone, a lot of the designs that you'll be making and a lot of the project stubs will have the design and layouts optimized for iPhone. So you can still follow along with everything we do in the course with an iPad, but just be aware that some of the designs might look a little bit stretched and they might not look exactly the same as you see on the iPhone, but it will work just fine. If you don't have an iPhone, you don't have to run out right away and get one. This is something that I would recommend, once you realize that you're really into this, or if you're at the point where you're about to release it on the App Store, then you have to test your app on a physical device. It's at this point when you would actually get an iPhone. So as I mentioned, Xcode comes bundled with a iOS simulator, and it's sort of like a virtual phone that runs on your computer, and you can essentially, use the rotate gestures, the shake gestures, you can zoom in and out, you can tap, etc. So it's just a simulated iPhone, and that works just as well. The only times when it doesn't really work so well is when you are using notifications, or if you're using Apple Health or Apple Home or some of those things, it can get a little bit tricky. Another thing that you should always ask yourself before you make any app is, do you actually need an app, or can you actually make do with a mobile responsive website? Now, because we have a mobile app development agency as well at the London App Brewery, one of the things that we tend to recommend, we have a lot of clients who come to us and say, I want you to make this app. And we actually spend a lot of time turning people away and telling them, look, you can get this made much quicker and much cheaper by just getting a web designer to make a website for you that's mobile responsive, that scales nicely on the phone. Because unless you're tapping into some of the sensors within the phone, say if you need the location, or if you need to be able to send people notifications, something that is inherent about the phone that you need. Otherwise, if you just need to display information, then making an app is a very time and money costly way of going about that. So always think about whether if you actually need to make an app before you make any app. And finally, we're just going to mention that prior to Xcode 7, so Xcode 6, in order to actually download the app that you coded up, that you developed within Xcode, onto your physical iPhone device that you own, you actually had to pay Apple $99 a year in order to be on the Apple Developer Program. So as of Xcode 7, so I think that was September 2015, when it launched, you are now able to do this on any free Apple account. So all you need is just your normal iTunes account, which you use to download apps. We'll be able to get your code and your app onto your physical iPhone device. Now, when would you consider signing up for Apple Developer Program? This is when you're ready to launch your app onto the App Store and start generating revenue. So I would recommend that try to delay signing up for the Apple Developer Program as long as you can, because you're charged on a yearly basis, rolling essentially. So if you're not yet ready to take advantage of the Apple Developer Program, if you haven't got your app together yet, if you're not ready to upload to the App Store, then there's actually no point paying Apple for that privilege. So build your app, test it thoroughly, Once you're ready and about to launch it to the App Store, then start paying for your Apple Developer Program license. And this gets you access to something called iTunes Connect. This is a portal where you can upload your apps, you can check your app analytics, how many times it's been downloaded, how many people are using it, you can check your sales, you can see how much money you're making every day, etc., etc. So this is something that we're going to cover in one of the last sections when we guide you through how to actually upload an app to the App Store. So all of that is coming up. All right, so those were all the tools that you'll need in order to get started. And in the next lesson, I'm going to show you how to install and set up Xcode so that you'll be able to get up and running very quickly and we can get started making our first app.